Hello everybody, this is the second part of the video. I originally thought I could explain this without drawing anything, but I really think you need to see what's going on here. So hopefully you've tried this, maybe you figured it out on your own anyways, but if not, I want to go over what we're doing here. So we look right there. So what I've done is I've drawn this right here. Actually, I'm sorry, we decided we need to reflect this across the line y equals 10. So we've decided that in order to make a downward arrow, make sure you can see this. In order to make this into a downward arrow with the point at 4, 10, so we want to have the point at 4, 10, and my drawing won't be perfect, but I'll be close enough. Basically, we want the same arrow, but facing downward with the downward point right there at 4, 10. So basically, look what we want to do. We just want to flip it over this line right here where y equals 10. So what reflection will do that? So here's the thing. If what we do, if we go from x comma y to, so in order to flip it upside down, if you flip it over the x-axis, let's make the y negative. Let's see what will happen. So if you go from x comma y to x comma negative y, so I'm just making the y negative, then this original image right here, we're trying to get it to there. If I flip it over y, then it'll be right here. So however, it's 2 to go up to there, so let's go down 2 instead. 2 up there, let's go down 2 instead. And then this is going to be at 6, so we go down, and this goes out to about -6. And then right here to 10. So look at what would happen if you take this and you flip it over the y-axis. Boom, now you're facing down. So we're facing down like our final image is supposed to do, but we're all the way down here. So just having it xy, x comma negative y is not good enough, because now that it's here, the point right here is at 4, -10. See that? It's down here at 4, -10. It needs to be up here at 4, 10. So this whole thing needs to move up how many places? It needs to go up. We want it to go from here up to there. It needs to go up 20 places on the y. So what we get here, if you just add 20 to the y value, that's what we want. So the final answer needs to be x comma y turns into x comma negative y, and then you add 20 to it to make it go up by 20. You see that? So basically it's flip it over the y-axis and then add 20. And so when you look, so we're looking for x comma negative y plus 20, and you'll notice right here, what it did to make it a little neater, this would be the same as negative y plus 20, but instead it just put the 20 in front, so you have 20 minus y. Same exact thing. So this is the answer you want there. Okay, let's look right here. How could this equation be written as a function? So let me draw what we have right there. So we have an arrow that starts at, so we have 1, 2, 3, 4, 5, 6, and let me zoom out. So we have an arrow that it starts in between 4 and 5. And it goes out to about 2. And then it goes up, and we're at 4, 5. Okay, so what we have here, we're trying to find what kind of reflection will get us from here and turn it into that. So this is the final answer we're looking for, is this right here. So in order to do this, we first need to flip it. And if you look, is that light in the way? Okay, so if we look at this, if I flip it right here, so if I flip it right there, what would happen. Let me be a little bit more careful and get this to scale. So this right here is at 4, 5. So 1, 2, 3, 4. So we'll be at negative 4, 5 will be our point. Once again, I'm not doing it perfect, but look, this point was originally at 4, 5. Now we're going to have a point. If you flip this over the y-axis, your point right here will be at negative 4, 5. Notice that on the new one, the point's at negative 4, 5. So I'm taking this and I'm flipping it over the y-axis. To flip it like that would be going from x, y, and we're making the x negative. Okay? So we want to make the x negative, it flips it like that, but now it has to move from here over to there. So it has to go from x being negative 4, scoot it over there, so x is 4, so it has to go up 8. So originally, so if you do x, y into negative x, y, that will flip it over, and then we need to scoot it to the right 8 places. So what we'll get is we get 8 minus x, y. Or I could have written negative x plus 8, but on the last one, you see what they do? They'll just put the positive in front. So that's what we do in order to scoot it over there. Okay, so now the last thing that we're looking at is this idea of a line of symmetry. So if you look at this figure right here, it has something called reflectional symmetry, because what happens if you take this triangle ABC, and flip it over the line BC, notice you have the same triangle on the other side. So basically you could draw this line in the middle and you have the exact same figure on both sides. That means this object has reflectional symmetry. Okay? It also has reflectional symmetry across line AD. Because if you take this triangle ABD and flip it over line AD, well, you have this triangle down here, ADC. So it has two triangles on top and bottom that are reflections of each other, and a triangle on the left and right. That's called reflectional symmetry. And then this line, for example, BC and then AD, these are called lines of symmetry, meaning they're lines that you can draw and you have the same figure on both sides. So look at this right here. This triangle has one line of symmetry right up and down through the middle. Look at this right here. How many lines of symmetry? It's got 2, up and down, left and right. How come there's not a line of symmetry going from corner to corner? Well, because you have 2 different shaped triangles on each side. If this was a perfect square, you could go from corner to corner. On a rectangle, you can't. Look at this star. This is going to have 6 lines of symmetry because you could go from the point to the point, point to the point, point to the point, and then you'll have a half star on each side, or you could go from where it dips in, and you could cut it across that way. So what I want you to try to do, how many lines of symmetry exist? I want you to try to answer these 4, and then you'll be done. So press pause, try to answer those 4 questions, and then press play and see me go over it. Okay, isosceles triangle, you could draw a line through the middle, and that's all you're going to get. So this only has 1. Circle. Wait, did I miss one? Yeah, the rhombus. Let me go back to the rhombus. You could draw a line from top down to bottom, right through the middle, and you could also cut it in half going across here. So rhombus has 2. Isosceles triangle has 1. Circle, I could cut it in half right there. I could cut it in half right there, right there. You could cut it in half wherever you want, infinite times. So this is the weird one that has an infinite number of lines. And then look at the square. Kind of like that rectangle, your example, I could go from the middle and I could go across. I could also go cut it in half like this. But because it's exactly the same, look at this. If you go from here and cut across the corner, you'd be making 2 identical triangles on each side. And you can also do the same thing from corner to corner over here. So that gives you a total of 4 lines of symmetry. So that is it for this lesson. As always, if you have any questions, just send me an email.